Welcome, everyone, to the ecosystem track. We have our first session today from HPE, and I'd like to introduce Matt Foley, who will be covering reduce op costs by 50%, get the cloud in 5 days, and other such miracles from HPE and Docker.
Thank you. Thank you. So greetings, everyone. All right, this is up and it's working. So glad to have you all here. My name is Matt Foley, and I manage a team of software pre-sales architects here in EMEA. You may notice from my accent that I'm not necessarily native to the EMEA region, although technically I qualify as Irish from ancestry. But I've lived in Europe for the last 8 years, and I came over here to work in the telecom industry. Prior to that, I was part of the design team for the Blade system and some of the other server products that some of you may be familiar with from Hewlett-Packard Enterprise, some of those products that have long been the foundation of the IT industry. And so the purpose of today's discussion and today's presentation is to show you what it is that we're doing as an infrastructure vendor in order to help our customers implement Docker, in order to help our customers move to containers for their applications in ways that don't impact the running of their existing business and their existing workloads and activities. And that actually is the hallmark of what it means to be a professional in the IT industry. So our job isn't just to introduce new technologies. Our job is to introduce new technologies and implement them in a way that it doesn't kill what went before. Because one of the benefits that we have as an industry is we get to solve the same business problems over and over again, just using new and different tools. And Docker is one of those new and different tools which come along every 10 or 15 years that really revolutionizes the way that we can actually implement, manage, support, and deliver our information technology. So just a quick thing here. I'll go through a couple of corporate boilerplate slides just to introduce you to our point of view and who we are and what it is that we're thinking about from a Hewlett-Packard Enterprise perspective. And you can see, of course, the typical profound slides that or profound statements you normally see in a keynote about everything being connected and everything being intelligent and all of it being able to be understood. That's enormously important. And the part that I've been most focused on is the idea that technology will be embedded everywhere. And that was really the key to our OEM activities here in Europe, which is what I came over initially to support 8 years ago. From our perspective, what is an OEM customer? What does that term actually mean? Well, we're an IT company, and normally our market is the chief information officer or the IT department in a particular enterprise. That's who we build our marketing for, that's who we build our products for, that's who we build our entire approach to serve. The OEM space was fundamentally different. These were customers that actually took our products, purchased them, put them into their products, and then sold that solution on to other customers. The best example was in that telecom industry. So Ericsson would buy our servers. Before we were here, they used to buy Sun servers. They would buy our servers, they would integrate them into network nodes that would do various functions, things like operational support systems and radio control. And then they would take that network node and they would sell it to Vodafone or some other operator like that. That's what's happening, though, across the industries at large, is that technology from the IT space is becoming more and more embedded into everything that we do and all of the other sectors of the society and sectors of the economy. That's a good thing from an IT perspective. It's a good thing probably from a feature perspective. What's not really understood and what's not articulated often is that IT entering those industries we may or may not meet those needs very well. So all of those other industries typically have different regulations. All of those other industries typically have different service level agreements. All of those industries have different penalties for failure. And so the traditional IT penalty for failure of, thank you for calling, just reboot your system and tell me if the problem's still there, that doesn't work in a lot of the regulated, serious industries that we're now entering. And we as Hewlett-Packard Enterprise want to help our customers get through that and get through that transition. Again, it goes back to the beginning. We're IT professionals. We need to implement IT in ways that don't kill what's actually been before. That's becoming a bigger and bigger burden as we move forward. So who is Hewlett-Packard Enterprise? So I'm confident that most of you all know who Hewlett-Packard is or was. And so Hewlett-Packard started 75 years ago. It made its name through test and measurement. In the late 90s, the test and measurement division was spun off into a company called Agilent, and then HP doubled down on the IT industry and purchased Compaq, which had itself purchased Digital and Tandem and a few others. And then, in addition, turned around and purchased a large IT services firm called EDS, as well as a bunch of software companies. That was the legacy of Carly Fiorina and later Mark Hurd. And what happened after the madness of King Leo Apotheker, what happened is that we now have Meg Whitman, and Meg Whitman has spent her last 5 years undoing all of that. So what you see before you is Hewlett-Packard was a very large company, and then it was split in half. One half was the PC and printer division, which lives on as HP Inc. The other half was Hewlett-Packard Enterprise, and still is. So move that to the side and bring forth Hewlett-Packard Enterprise. We've now split again 3 ways. So the part that used to be EDS, in our terminology, it was Enterprise Services. That's the IT outsourcing arm. That's actually gone off and married another company called CSC, and they've now formed another company called DXC. So that lives on under that brand. The software group married Micro Focus and actually kept the same name. So it's now a much bigger Micro Focus, but that's where the software portfolio is, and that's the ITOM software, the Mercury software, Autonomy most famously. So those are the companies that we were. And the company that we are now in Hewlett-Packard Enterprise is focused specifically on IT infrastructure, server, storage, networking, and then the services around it in order to make it work and in order to provide advice as to how to use those services. And so we've come down to the strategy, and these are fairly simplistic strategies. The first one is we're trying to make hybrid IT simple. One could argue we've gotten rid of a lot of the products that would have made it complicated or that would have made it difficult. And also, we're looking to invest heavily in this edge. We really are betting that that is the trend that will save us in the future. That is the trend that we will use in terms of growing our company, because we'll be embedding our IT technologies in that edge. Now, how are we doing this? So from an IT perspective or a hybrid IT perspective, we're trying to make it simple by actually providing the endpoints into our infrastructure that make it behave like the infrastructure you're seeing in a public cloud. Make it responsive to APIs. Provide the flexibility that you need so that you don't have to buy a virtualization layer just to do it. All of those things are important, and that's what we're doing in hybrid IT, and that's what I'll explain in this session. From an edge perspective, we are working with a whole variety of industries, and they're all still so different that it's impossible to have a single Internet of Things market. But we are working in order to make that possible as well. The other piece is with regards to applications and data. The era of informal IT or amateur IT, amateur hour is essentially over from an IT perspective. So what it is now is we need to be professionals from an IT perspective. We are going to come under significantly more regulatory schemes, significantly more burdens that we have to bear. And the only way we're able to do that is if we provide the modern infrastructure, the modern experiences, the modern control points that our customers have come to expect from services that they don't have on premises. So those are the key things going forward, and those are the things that we as an IT company are looking to provide to our customers to help them adopt this technology for their benefit. So what is going on in the market in response to these trends, in response to the need for flexibility, in response to the need for speed? We are seeing, as you would expect, a shift to the cloud, both public and private. So the amount of private infrastructure overall is shrinking, and the amount of private infrastructure that is now a shared resource or a private cloud of some sort, that part's growing. So the traditional infrastructure, the traditional client server market is shrinking very, very quickly. And we're certainly seeing that as we look into our customers and we look into our partners. We're definitely seeing that. Our job is not to fight this trend. Our job is not to roll back the clock. Our job is to actually accelerate this trend, to help our customers most effectively use the equipment that they have, use the IT technologies that they have for their benefit. So our job is to accelerate the transition of all of their infrastructure towards shared resources. And that's where the Docker parts come in. Now, we do talk about the maintenance burden of the existing infrastructure, and that's always pegged at somewhere around 80%. Mr. Pareto was always right, I guess. But fundamentally, what this is actually a dynamic situation, not a static one. And by that, I mean companies were normally organized with a central IT department and various lines of business. Those lines of business paid a tax a central corporate tax to fund the IT department and fund their activities. As the lines of business have had more and more digital content integrated into their products and integrated into their business, they've taken more control of that IT budget and they've stopped paying as much of a tax to the central teams. So as a result, the issue is more that the central folks' budgets are actually going down. And so their maintenance burden, while it may be staying the same, is actually increasing as a part of their budget. This is a vice grip of death, if you will, for the central IT department. And so what we want to do is we want to help these folks because these are our customers, right? We are an infrastructure company. We support an infrastructure community. We enjoy doing this. This is who we are and what we do. I'm an old hardware guy. It was fun. And we want to help these people. We want to help these departments. We want to help these companies get the most out of their internal IT rather than just turning it off and shifting it outside where they lose control over costs as well as other features and functions. So how do we help them get there? The first way to help them get there is by changing the infrastructure that they're running on. You can see we go from traditional to converged to hyperconverged to what we're calling composable. Now, traditional infrastructure, it's funny to think of client-server architectures as traditional infrastructure. When I entered the industry, traditional was mainframe, and the client-server stuff was the new and exciting stuff. But nonetheless, it is traditional. And as we moved more and more workloads to virtual machines, instead of just putting them on the bare metal, we then realized that most of the workloads were virtual machines. It's fairly complicated, or the setup we had was fairly complicated just to support that one workload. That's why converged infrastructure came into being. And what it really was just a consolidated tested block of infrastructure that supported VMware, typically. That's what a vBlock really was. You can argue whether or not that approach has aged well in data centers in the last 6 or 8 years. Nonetheless, that was the point. Beyond that, in the smaller sites, Hyperconverged came in. So instead of consolidating 3 different silos into one box, now we're actually taking those same functions, implementing them in software, and putting them on a single box. This takes advantage of a couple trends. One is the workloads really haven't changed. It's the same virtual machines or the same applications that we've been running a long time, but the hardware underneath has changed dramatically. It's probably 10 times faster. And so as a result, you're able to put that amount of workload for, say, a store, a branch office, a remote site. You're able to put that workload on much fewer servers than we did in the past. So we no longer need a whole blade chassis. We just need a couple of hyperconverged machines. Now we're moving to composable. And the point of moving to composable is to try and get the management flexibility that you required and the reasons why you're using virtualization to embed that into the hardware so you no longer have to pay the virtualization tax, and to make your infrastructure flexible and responsive so that you can actually make this work. Now, we saw in the keynotes today about how easy it is to take a Docker application, make it a container, and put it somewhere else and start managing it in that framework. And it's very true. It's the same thing we did 15 years ago with virtual machines. We took the virtual machine, or we took the base machine, we virtualized it, and then we were able to manage it flexibly. That allowed people to standardize on VM farms, for example. So we're getting out of the reasons why we virtualized in the first place. So the reason we virtualized in the first place, in case you're wondering, is because Microsoft couldn't multitask. That was the fundamental issue. We had one application per server, which was the rule, and as a result, as the servers got faster, the application stayed about the same. We had tremendous amount of underutilization, and it was easier to just emulate the entire server and run multiple copies of those on the same machine rather than having to stack applications on a server. If you think about it, though, that's what an OS should have done. We should have been able to run more than one application on a server. Because we couldn't, we invented virtualization. Because we had virtualization, we invented the management techniques. And now we're back to a point where the OSs can support multiple processes well in an isolated manner, and we don't need the management structure that we built for virtual machines. But we like it, so we want to keep it. And that's what Composable gives you. So the program that we are working on with Docker is the Modernizing Traditional Applications program. So Hewlett-Packard Enterprise is a large company. We will probably, at the end of this latest organizational shuffle, have somewhere between 40 and 50,000 people. Somewhere around 20 or 25,000 of those are consultants in the services division that can help customers take their applications and move them into modern architectures. So the first step is to optimize the hardware that you're using. And what this means is by taking those applications and putting them in containers, what we're finding what Docker's finding is that we can save about 50% of the hardware and 50% of the infrastructure that you were using. That was validated again today on the in the keynote. That's a big savings. That's a big deal. And we talk about this area where 80% of our budget is going towards maintenance of the existing infrastructure. If we can cut that in half, then we will have some positive impact on the budget, and we can take that positive impact and we can actually put it into refreshing the equipment so that we can get to a modern architecture and start delivering the products and services that we need to deliver as an IT company. And so by taking the savings, accelerating a hardware and an infrastructure refresh, then you're able to provide a positive or a good platform for those applications to land on, as well as the appropriate platform for the development of new applications, or the appropriate platform to better support a CI/CD lifecycle or a DevOps pipeline and those types of things. So those are the areas that we're focused on, and the parts that HPE is bringing to the table is, number one, the infrastructure. By making our infrastructure easily programmable, that allows us to better fit underneath these other activities. The other part is with storage, and you'll see some of that later, where we have storage plugins and we're able to provide enterprise storage capabilities to containers, which is something that is necessary if we really want to make sure that these applications move appropriately, that we can actually make the transition and modernize these traditional applications. We start off with a pilot service. So this is a service. Docker MTA is a defined service, and it's available from Hewlett-Packard Enterprise and others. And so we have a pilot service of this, and the pilot service is where customers typically start. So they start with a month-long engagement, 1 week on site, 3 weeks remote. And in that, we containerize 1 to 3 applications, and we start to work on how to deploy them. We deploy those applications successfully to Docker Enterprise Edition. And this slide, even though it's got a fair bit of words and it looks like a lot of the other slides that you may see, it actually contains the most important part here of what it is that's necessary in order to make the transition. The deploy app stack to Enterprise Edition. That part, I submit to you, is the difference between the old IT and the new IT. So we grew up as an industry focusing on networking specialties or storage specialties or server specialties. We all had different certifications that we could use. There was the Master ASE from Compaq, there's the Cisco CCIE, for example. We are certified, we are trained, we are working in those areas. That's what we're focused on. We're focused on the infrastructure part. And so our job as an industry, our job as a computer supplier was to build you the best computer that we could build. And then we would give that computer to a distributor. We would sell that on to a reseller who would sell that on to an end customer. And that is typically how the supply chain worked. All of our marketing was based around the factors of the physical factors of the products. None of it was really based on anything else. We weren't basing our marketing on applications, maybe to the operating system level, but that was it. Today's IT is all about the application. Infrastructure be damned. We don't need to really have those specialties anymore. And the way to make the jump from infrastructure to application is in that deployment to Docker Enterprise Edition or something similar. What I mean is that your application is no longer a CMDB and a bunch of install scripts of how to put this on bare metal. Your application is actually a software template, a live software template that you actually push into a management structure, and that management structure then sets up the application or modifies the application or scales the application or shuts down the application. All of your applications are services. All of those applications need to be represented as templates that are compilable, that are able to be used by automated orchestrators in order to implement your IT. That's not an easy skill. We can make it easy, we can do demonstrations and all of those things, but fundamentally the IT departments that implement this strategy, they will have a script library that they will have to maintain in perpetuity. They will have these frameworks, these Docker Compose scripts. They will have to maintain those perpetually. That's a burden. That's not a light burden to bear. And so the key here for making the transition between the old and the new in terms of IT is to change your perspective. Instead of going from the bottom up, which is what we've historically done, we need to go from the top down. We need to go from the application in. And that's what the Modernizing Traditional Applications program is really about. It's about changing your applications, not so much physically, in fact, the code doesn't change at all, but it's really changing the perspective of how you manage, how you maintain, how you work with, how you deploy. It's changing the perspective of what you do with those applications that matters. And it's a big deal. I've seen companies and customers who have played lip service to this. Yeah, we'll do it. Or no, we'll put this over where the developers like to play and they can do whatever they want to do, but we will still manage our IT in the same way we've always done. And they typically wind up losing. My fear is that for the customer base is not competitive. We have very good competitors in all the markets that we compete. That's not the point. My fear is that because if our customers don't adopt the perspective of the application, that we will lose our customers to irrelevance. That's the bigger concern, is that people who are focused exclusively on the infrastructure domain and doing it the way that we've always done before will simply be bypassed. So modernizing your traditional applications is one way to learn and understand and use these skills so that we can work from the application down. And that's the key point, the whole thing. If you don't get that, then you won't get Docker. If you don't get that, then you won't be able to participate in the cloud-based economy. That's the whole thing in terms of making sure that you have automated your deployment and automated your activities so that you can manage these applications as applications rather than silos of infrastructure. The common use cases that we have, so the first one is, of course, cost savings. And that's just a basic slam dunk, as we would say in American basketball, sayings. It's an easy one. You put your applications in containers. You no longer have to emulate the entire operating system or the entire machine that it was running on. That saves about 50% of the capacity and the space that you normally would have. That's pretty good. It's not a bad thing. The other purpose is to migrate applications. So if you can take your application, put it into a container, put it on a different machine, and retire that 5-year-old server because it's no longer really serving its purpose, it's out of warranty and it's getting expensive, it's not power efficient, all of those things, that's a win as well. But the main benefit is really the faster delivery. The faster delivery part is key, and the faster delivery only comes if you take the advice earlier of really viewing your IT estate as a collection of applications rather than a collection of middleware or infrastructure. If you adopt that viewpoint, if you really standardize on application templates, if you standardize on that way of doing things, you will be able to do the deliveries faster. If you don't, then you won't. You'll just have the same application running in a different way, more efficiently. It's not a bad thing, but you're not taking the full advantage of the platform that you otherwise could. We saw MetLife a lot, and they're actually doing presentations, and they're all here and everything, so I won't belabor the point on the MetLife example. This was a single application here where you can see on the right side all of the things are, it's faster to deploy, better utilization, all of the security patches are easier, the time to scale is much shorter. All the things you'd expect from implementing a container platform, they've happened here. Another customer was a major U.S. mortgage company. This was a different application because it's a .NET application. It's part of the Microsoft ecosystem. So something like 80% of the enterprise apps are either Java types of things or .NET. And so as a result, we needed to support both. I remember back when HPE was really doing a lot of work in Cloud Foundry, we were the ones who would actually put into the Cloud Foundry community, we actually put in the .NET support. So this is a big population, and a lot of customers do have .NET applications. And even here, they were able to see similar results. And you'd expect it. Again, you put this into containers, you're no longer emulating the whole OS, and you're able to manage and control things in a better, more efficient way. It's just a better way to run a railroad, a better mousetrap. It's an easier thing for everyone to do. So there are 3 deployment options that we come out with for the modernizing traditional applications. So those 3 deployment options are, first of all, if you want to go large or large scale, this is where our enterprise blade platforms fit well. So I came up through C-Class, but we've now replaced that with Synergy. So C-Class had a nice 10-year run. It was number 1 for the entire time in the market, which is kind of rare for a hardware platform. But Synergy has now replaced it. And Synergy, while it has the physical attributes that you would need in order to support the modern hardware generations of processor and memory and I/O going forward. The major benefit here is that we've significantly changed the way that we do our management. And the way that we do our management now in Synergy is that we're able to specify more clearly exactly what it is that we need from a resource perspective. If Synergy is too big, SimpliVity is a just right size. It's a small enough size. This is our Hyperconverged Platform. So SimpliVity is it's really based on a data architecture, a storage architecture called OmniStack. But SimpliVity it's our Hyperconverged Platform, and we have bundles here that we're able to provide with Docker Enterprise Edition so that it can stand up easily for both administrators and developers alike. And then for those who are doing fairly small proof of concepts, of course, everything still works on a standard server. So just to dive a little bit more into Synergy, what this really does. So we, as a hardware vendor and as a server maker, have long tried to tailor our servers to specific applications. We still do that today. So for example, if you're running SAP, we have a giant server with a massive amount of memory in order to fit the in-memory database, the HANA database in it. Other servers, we have 4 processor servers with a lot of cards. We have 2 processor servers with a lot of drives. We have 1 processor servers with not that much. You see what we've got. We've got all this huge portfolio of servers, and it's intended so that you don't have to overbuy the server for the application that you intend to run on it. As we homogenized the environment with virtual machines for the applications, as an industry, we homogenized the infrastructure, which is why the 2U server, the DL380, has actually been the #1 selling server in the world for 15 years. Because that DL380 was powerful enough to run every application, and it was just dense enough to qualify as being dense, and it was big enough to cable. Those were nice. That was a nice way to do that, but we lost some performance in the process because we were just running everything on the same machine, whether it was really optimized or not. What Synergy intends to do is give you the flexibility to define that entire portfolio. If you want a 2-processor system with 30 drives and 6 NICs, you can do it. If you want a 4-processor system with 8 drives and 12 NICs, you can do it. If you want a 2-processor system with only 2 drives, you can do it. You can define it. You define these in templates, and that's how they work. You define this in the templates in Synergy. And those templates are API driven. If anything you saw today from the demos, everything needs to be API driven. So we're driving this with the API, defining the architecture, and that's what we're using here to support Docker. And that's what we're using to figure out how to make it easier for our customers to implement this in their data center than it otherwise would be. So specifically here, this is the reference architecture, and you can see we've gone both virtualized and bare metal. And it's because Synergy can actually do both. So for the control plane, which needs 9 servers, it would be a waste to put all of those on bare metal systems, even though we could just as easily define those servers and put them there. But it's not something that adds any value, and in fact, it's a significant cost. So it's better here to virtualize those servers in the control plane so that you don't have to waste a lot of hardware and management. Whereas the worker nodes, the Docker worker nodes that participate in the swarm, those actually don't need to be virtualized, because they're all running isolated processes anyway. They're just places where containers are landing and containers are spun up. So they don't need to be virtualized. And as a result, we're able to achieve a significant cost savings because we don't have to pay the virtualization tax. Performance benefits as well because we don't have a hypervisor in the way. And it's far more scalable because we're able to assign bigger blocks of capacity because the physical servers are significantly bigger. So we're able to do all of these things, and we're able to make it flexible in one platform. And that's really the primary reason why we believe Synergy is a very good fit for container farms that folks want to spin up, because we're able to programmatically control this infrastructure, define the specific servers we need, and even boot into the operating systems fairly quickly. So that's the other part of Synergy as well. So not only do we define a server, and by that what happens is when I request that 2-processor, 8-drive server with 4 NICs, just to use an example, the system goes out and finds the processor memory complex. It connects it then to 8 drives in a physical way, and then it actually connects it to the NICs, and it boots that up and presents that as the base layer, the physical layer, which then the operating system can see and use. That's what it is. You're not actually defining that specific server in the infrastructure. The management infrastructure is going out and just finding the one that fits. So because of that, because we're able to do that, and because we're able to apply the operating system so quickly, we're able to spin up new Docker nodes in 5 minutes. And as a result, these are new physical, base, bare metal Docker nodes very, very quickly. And because we're able to do that, we're able to emulate some of the management intelligence that you've come to rely on virtual machines to provide you without having to pay for it, without having to have the hassle of version controls and all those sorts of things. So we're able to provide that fairly straightforwardly. With regards to simplicity, so this is our Hyperconverged Platform, and here we've created bundles which work in terms of providing either a quick way to spin up Docker Enterprise Edition for developers and a quick way to spin up Docker Enterprise Edition for IT operators. So for the developers, there are a significant amount of third-party content that's available that is part of the package, things like Jenkins, that's in there in order to support the developer use case and support how they get that going quickly. So this would be, for example, an IT customer or an IT department wants to experiment with Docker Enterprise Edition and they want to help their developers. That's an easy way to go do it. Additionally, if they wish to have Docker Enterprise Edition in production, we have a different bundle which actually provides a lot of the HA features that has that enabled by default, which is sort of what you'd expect from an operations perspective. So that's what we're doing from those two things. And then the last one is with regards to storage. So one of the hardest questions to answer, and I think it'll still be the hardest question that we'll continue to answer, is what do you do about storage? Docker is wonderful for apps that aren't stateful, but if you have a stateful application that relies on some storage infrastructure that has enterprise features, how do you really modernize that app? How do you modernize that traditional application? Because it actually is relying on the storage, and if that storage is not there and it doesn't have the same capabilities and the same features, then it's going to be difficult to take that application into containers and even further into the cloud. So we do have qualified plugins for all of the infrastructure, the storage infrastructure that we support. So it's 3PAR and Nimble are the typical names that you would see. And then we also, of course, have these plugins, and they're not only available to just the Docker orchestrators, but also they're available to the other orchestrators. And apparently Docker is now available to the other orchestrators, as we saw in the keynote today as well with the Kubernetes announcement. So those are important, and it's important to be able to have those qualified plugins so that we can still provide volumes of storage that have the characteristics that are required for those applications. But that's a problem in that so long as that application doesn't leave your data center, that's okay. But as soon as you want to take real advantage of all of the Docker features and all of the really modern IT features and move that application flexibly to cloud infrastructure all around the world, you're stuck. You're stuck because you still have those volumes in your data center, and it's tough to get them out. That's where Nimble came up with the idea of cloud volumes. So Nimble has its own hosted storage, and it provides a storage service that's accessible to the other clouds. So for example, if you have an application in AWS, that application can mount a cloud volume from the Nimble service. And so as we've got customers moving this around, we're taking volumes from their data center, putting them into the Nimble cloud volume. That means that volume is now accessible to all of the other infrastructures within a certain amount of radius. Right now it's available in the US. But the point is that actually frees the application to then be able to use the other infrastructures that are available in the market. And that's important. So it's steps here. We're trying to make sure that we move forward. Another argument could be that as you modernize your application, you use storage that's different, and you're able to architect the storage so that it doesn't need these enterprise features. But the theory is, here at least, that if you're not touching your code, you're probably not going to want to mess with your storage either. And so as a result of that, we're trying to find ways to provide those same storage features, those same volumes, the same resiliency, the same snapshots, all of those things. We're looking to provide them as a storage service so that you can take advantage of Docker containers, not only in your data center, but also around the world. So the criteria checklist for modernizing traditional applications is fairly standard for a service engagement. So first of all, we have to understand whether or not the people who do this work are available to do it. And so we're continually getting more people who are capable of doing this, but also the service itself is taking off in terms of people really do want to have this type of service for their IT estate. The infrastructure requirements you can see there, a minimum of 6 servers in most cases. The application requirements, we're really looking for Java applications or .NET applications. That's the typical sweet spot for this. Others may apply, and I'm sure there can be special arrangements to make those work as well. But fundamentally, those are the applications that we typically see, and those are the applications we're typically focused on. And then from a personnel requirements in the customer, we need a business sponsor, and we also need the subject matter experts on site to understand the application portfolio that you have. But this is the most important part. So remember the thing I said earlier. The thing I said earlier was the only lesson that I want anyone to take out of this is that in order to succeed going forward in IT, we need to change our perspective and view our IT from the applications down rather than the infrastructure up. And the only way to make that bridge, the only way to make that connection is to actually work on the scripts, work on the templates, the application frameworks that allow orchestrators to automatically manipulate the applications that you have. So the fundamental key here, for success is whether or not you commit to writing and maintaining those application templates and those workflows in order to modernize your own IT estate. Because we can only do so much. We can modernize a few applications, show you how that's done. But if you don't take that fundamental lesson that the applications need to move to containers, and once they do that, you're no longer managing servers. You're managing templates for applications. Until you make that mental leap, there's no way that the lesson will stick. And so that's why the executive sponsorship is so important. That's why it's so important to have the subject matter experts who really understand the applications. All of that is a key thing in order to have success in this going forward. And last but not least, so we are here. There's a lot of us here from Hewlett-Packard Enterprise. We have a booth, a very attractive booth, I would say, out on the show floor. We have 4 areas of expertise there. So the first one is synergy. So there's a synergy representative there and can speak to you about how the platform and the APIs work so that you're able to define hardware in software, if you will, in order to support the automations that need to be made. The next one is SimpliVity. So the SimpliVity team is here, and they can describe to you all the benefits of OmniStack and all the benefits of being able to use a hyperconverged platform that has a data path that's really built for performance and resiliency and also redundancy. So they can do a much better backup than most can, just because of the way they've architected their storage. The next one is the Modernizing Traditional Applications booth. So that is where our technical services team, now called Point Next, that's the brand name for it. Our technical services team is available to answer any questions about contracting the service, figuring out when it could be done, how to take advantage of the 30-day offer, all of those things. That's there. And the fourth one is Nimble. And I certainly encourage you to take a look at the Nimble storage booth and understand cloud volumes and understand how Nimble is actually going about and solving this data problem, this data migration problem, in a pretty unique and pretty effective way, and also how Nimble manages storage generally, which is, of course, one of the reasons that we now bought the company is because of the way that they manage and support their customers. So with that, I will take my leave of you. So thank you very much. You've been a kind audience, and I wish you a very productive week here at DockerCon.